This problem describes a solid that is created through cross-sectional semicircles on the given base that are perpendicular to the x-axis. So we begin with a sketch of this space in 3D. We need a z-axis, an x-axis, and a y-axis. Y equals to 0 is our x-axis, so we mark it in red. X equals to 0 is our y-axis, we mark it in green. (2x plus 3y equals to 6 is a line in the xy plane that crosses the x-axis at x is equal to 3 and the y-axis at y is equal to 2. So here's the line 2x plus 3y equal to 6. Let us shade this region that denotes the base. The solid is created with semicircles whose diameters are on the base and perpendicular to the x-axis. Let us draw a general semicircle on this region. Here's the diameter, and here's the semicircle. Now we draw the last semicircle, and perhaps a few more in between, so that we get a sense of the solid. To set up the volume of the solid with an integral, we need to know the area of a general cross-section, in other words, the area of a general semicircle. And here is a general semicircle. In order to determine the radius, let's notice that the base of this semicircle is actually y. That means my radius must be y over 2, half that of the diameter. Since we know that 2x plus 3y is equal to 6, we need to solve this for y and get that y is equal to 6 minus 2x over 3. Now we are able to express the area of this semicircle in terms of x via the variable y. Namely, the area is half radius squared times pi, and the radius is y over 2. And after simplifying, the constant coefficient is pi over 8 times y squared, and since we know y in terms of x, we make that substitution as well. And since we know that we eventually have to integrate, we may as well simplify this even further. Now 3 squared is 9, 8 times 9 is 72. And then sorting the terms from highest degree to lowest, negative 2x all squared yields 4x squared. The middle term is negative 2 times 6 times 2 gives us 24x, and then 6 squared gives us 36. We are now in a position to express the volume of our solid. So V is equal to the integral from a to b of the area of a cross-section integrated with respect to a suitable variable. In our case, this means, well, first of all, our cross-sectional area is the one that we've just found, namely pi over 72. times 4x squared minus 24x plus 36. And since our semicircles have the diameter cutting through the x-axis, we're integrating with respect to x. And these diameters run from 0 all the ways to 3. It is easy to integrate this integral. We get pi over 72 times 4 over 3 x cubed as the antiderivative of the first term, minus 12x squared as the antiderivative of the second term, and lastly 36x for the last term, all of which needs to be calculated over the interval from 0 to 3. Since our lower bound 0 will yield a value of 0, we only are concerned with the upper bound. So this is pi over 72 multiplied by 3 cubed, cancels with one of the 3's in the denominator, so 3 squared, which is 9, times 4 will give us 36. Minus 3 squared is 9. 9 times 12 yields 108, plus 36 times 3 is also 108. Negative 108 plus 108 is 0, and 36 over 72 leaves us with a half, and we get pi over 2 cubic units for the volume of the given solid.